A very cordial welcome to the DiBiCoo study tour, today in Scheibbs, Austria. DiBiCoo is an EU-funded project within Horizon 2020. The aim is to bring established biogas and gasification markets together with upcoming biogas and gasification markets over the world. The gasification plant in Scheibbs deals with about 6,000 cubic meters of wood chips per year. The electric capacity of the system is 220 kW, while the installed thermal capacity is 3 MW. Due to its 6 km long grid of district heating pipes, more than 170 households are supplied with renewable heat energy. The biomass required of gasification is already delivered as wood chips. The wood chips are sieved so that the gas produced in the gasification process is as uniform as possible and, furthermore, to achieve the best possible gas yield. Oversized chips are eliminated because they could lead to problems with conveying in the screws or to the formation of bridges in the wood gasifier. Fine fractions are separated out because, on the one hand, they contribute little to the gas yield, and on the other hand, they could lead to dead zones in the gasification process. These separated wood fractions are then burned in a standard wood chip boiler to produce heat. Most of the wood chips are of a relatively uniform size and are dried in advance. The drying takes place with part of the waste heat from the wood gasification and is intended to ensure that the wood gas produced can be generated as dry as possible. A safety port with a double lock is arranged between the conveyor screws to the wood gasifier so that no false air is transported along with the wood gasifier. This ensures that there is never a direct flow of air from the wood chip store into the gasifier. The wood gasifier used here is a fixed-bed direct current gasifier. This means that both the wood chips and the supplied gasification air have the same flow direction. The double safety port in front of the carburetor ensures that only air from the spaces between the wood chips is brought into the system. The wood chips are fed into the wood gasifier by means of a stoker screw, where the gasification process, the thermochemical conversion into wood gas, takes place. The wood chips are now heated by the supply of heat and the rest of them dries out. Pyrolytic decomposition begins at over 250 degrees Celsius, with gaseous pyrolysis products and sometimes undesirable tar emerging from the wood. The products formed during pyrolysis, such as tars, coke, carbon monoxide, carbon dioxide, hydrogen and methane, are partially burned or cracked in the oxidation zone. The gasification medium used is preheated air, which is blown in through nozzles in the area of the oxidation zone by a side channel blower. The air supply is restricted in such a way that only a minimum amount of combustion occurs. This is called stoichiometric combustion. The partial oxidation provides precisely the energy that is required for the process. The process is thus autothermal. In the reduction zone, the carbon dioxide and water vapor produced during combustion are then reduced to carbon monoxide and hydrogen on the hot charcoal. Due to the special design and control of the gasifier, the wood chips are converted into a very low tar wood gas. Unequal exposure of wood chips to the wood gasifier could lead to flame breakthroughs on the one hand and dead zones on the other. Both are events that significantly disrupt the process of wood gas formation and must therefore be avoided at all costs. This is achieved on the one hand through the preparation of wood chips and in the wood gasifier itself through a compression tappet and ultimately through the rotation grate arranged in the lower area. After the wood gas emerges from the wood gasifier, it is first cooled to approximately 110 degrees Celsius in a heat exchanger and then cleaned in a dry fabric filter. In order to prevent the fabric filter from sticking and thereby losing its passage and cleaning performance and thus having to be replaced prematurely, a wood gas that is dry as possible and low in tar is essential. In order to achieve this low tar wood gas, the wood chips used are pre-dried to a water content of approximately 10%. In addition, the wood gas formed, in the case of the descending gasification used here, has to pass through the hot reduction zone before it leaves the gasifier. In this, at high temperatures and in the absence of air, the reduction of the wood gas and also the required tar breakdown takes place. Ultimately, the wood gas is only cooled down to the temperature at which tar condensation is avoided. The fabric filter itself is equipped with an automatic cleaning system. The resulting wood ash is in turn discharged by means of screws, conveyed through a water bath and temporarily stored in a storage container until it is used as a carbon fertilizer. The cleaned wood gas leaves the fabric filter and flows through another safety filter before it reaches the gas control system of the CHP unit. After the gas control system, it is used to drive the motor for electricity and heat production. During the startup of the wood gasifier, and if the gas quality is not suitable for CHP operation, the wood gas is burned via an emergency flare. The entire system is monitored and regulated by a central control unit. All safety devices are also monitored here. Ultimately, all processes and malfunctions are automatically documented. The control system basically regulates the system independently, based on the specified target parameters. However, these can also be adapted or further optimized. Thanks for joining the virtual DiBiCoo study tour. We hope you got interesting information about gasification of wooden biomass in Scheibbs, Austria. Please have a look at our homepage and have a nice day.